last spring, if you listen to Brian, you know, Mach4 is going to be here just any day now. Just, you know, real soon now.
For 3 years.
And I said, you know, if it's coming out, we better get some new wizards, because, you know, people expect that we'll have wizards. And, well, yeah, he said, let's, but the interface was, he hadn't even started screen designer yet. And he said, well, let's do them in C++. I had a C course back in 1990 or 91, and that was it. And I said, well, yeah, let's do that. So I learned WX widgets and C++ and Microsoft Visual Studio, and I thought a pretty reasonable set of wizards running. I concentrated on the operations that it did. But Brian came along and said, we got to do a lot better in the job control. If you remember, everybody in here used the old newfangled Wizard suite. You remember it would build up a complex program step by step for you. But you really couldn't edit it. If you looked at your program and said, darn that, step 2 should get moved down to step 3 or something. You really couldn't do any of that. So let's improve the job file. And let's store, save the job file. It really is just all of the inputs that the user has made. We can reload that job file and regenerate the G-code from it really quick. So the thing that's happened is a lot of improvement in the job file. Now I'll start it. As you see, it's just an icon on the desktop. It's a totally standalone Windows program. It can run on any PC. It ultimately was intended to run on Apple and Linux as well. It's just an application. It has nothing to do with Mach4. It has used components like the toolpath that's in Mach4 is also the toolpath display here. And the license code is the same license code. And I don't remember anything else that we lifted from Mach4. But the idea was to, you know, use compatible things with Mach4, but it's standalone. So it's just an application. I'll just double click application, okay? I don't know why it pops up that stuff. I'll move my laptop about that far back, okay? And it's got the whole screen, so we're okay on the way it expanded here. I'm just looking at mine. Yeah, it's got taskbar and everything else. So this is the screen that you see when it comes up. Toolpath window, obviously the thing that's in the middle of it. The things over on that side have to do with job control and the job that you're running, okay? And editing the pieces of the job and whatever. And you'll see that there's a button over there that says New Job, or a button that says Load Job, okay? You can save a job file, and you can reload it, and all the G-code will get generated again from it, okay? Down on this side are all of the operations that you can use and add into your G-code file. So the only thing to do first is a new job, okay? So we can either click the button here for new job. I can open this and get a tab for a new job, okay? So you can do it a couple of ways. We try to be kind of Windows standard. The new job window pops up. We have a material file. I'll show you how to edit that in a minute. There's a built-in material file that you can change. Right? And you must select the material. This job is going to be, we're going to be expensive today. We'll do something in brass. Custom code. There are people that say, well, I got this tool change and I have to do some initialize thing every time a G-code program starts up. Well, here's your window to put it in, okay? You can put in any G-code you want in there. Now, I'm not going to check it, so if it's, you know, drive the Z down to 43 inches below the table, you put the code in there. But you can write as much G-code as you want, and they say the intention being funny initialization strings that people need in a particular machine. There's a box over here for units. Are we working in inches or metric? And the program does all of the right things to manage the right numbers. But a job must be an inch job or a metric job. You can't do 2 operations in inches. You can put a metric tool in an English job or vice versa. Okay? So you can, when we get to the tool select screen, you say, you know, you found a good deal out here on 8mm end mills, then you can use them in the Wizard, and it'll take care of all the calculations. It immediately takes your 8mm if you're doing an inch job and turns it into inches, but it'll do it. The other thing, Z-step strategy. I did a couple of surveys on the web and said, when on G-step, when you enter a value for how deep you want to cut. Let's just take an example. I'm going to cut something 200 thou deep, and I say do it in 40 thou steps. Okay. Now, 40 thou steps doesn't exactly come out even to 200. I have two choices. I can make the 40 thou steps as you prescribed, and then I can make the last cut whatever it comes out to be. So I may make a bunch of 40 thou, and then I might make a 2 thou cut for the last cut. But I can have one strategy is as entered. You ask for 40, I'm going to make each step 40, but I'm going to make the bottom come out where you tell me the bottom is. The other one is an equal Z strategy, and I think the old wizards tended to do that. If you ask for 40 and 200, it would say, well, the best way, I don't know, anybody do the arithmetic on that? How's the best way to get
it works out fine.
Oh, 40 works? Yeah, all right, sorry, bad example. But you get what I'm talking about, okay? The program will either calculate a step less than your maximum, but the biggest step I can make to achieve your depth, okay? But that's, again, a job-wide setting. So I'm going to pick, you know, a Z-step of either equal or as entered, okay? The G-code comments, I like comments. I like to just fill the G-code with comments. And that's mostly for support, because I get these reports on the web form that says, I asked for a 3-inch circle and it gave me a 2-inch circle. And I say, you know, show me your G-code. And sure enough, there in the comment it says you entered 3 inches or whatever, you know. So I like it for debugging. Brian went nuts. All that junk, I don't want to see all that junk in my G-code, okay? So we got a check mark. You can have it if you like to see all the comments, or you can not have it if you want. And you can make a valid point. There are some old FANUC machines where people might be pretty happy to get conversational capability on a PC to run with it. And they have little tiny memories, and they don't want to clutter it up with a lot of comments. So you got a check mark. You can turn comments on or off. The next is rapid height. I want a number, and this is job-wide, that is, I'm free to make any rapid XY move. It's above all clamps and all fixtures and all vices, okay? And you give me a rapid height above your work, okay? Pretty obvious in the way that's going to be used. The other one is you give me a clearance height. Now what the clearance height means, let's say we were making our first move down to 0, where our first move is going to go down to 10 thou or something, a facing off cut, okay? I'll wrap it over at 1 inch above the work to my starting point on the job. I'll wrap it down to the clearance value. The clearance is really a distance. I really ought to say distance instead of height, because it'll go down until I am 50 thou away from my new cutting surface, and then it'll slow and go to feed rate and move in there. So you don't see it, you know, like some of the old things, your plunge rate is feed rate. You're watching it plunge down 1 inch for feed rate. I'll go rapid down, 50 thou above the work, or 5 thou above the work, depending on how gutsy you are. I can't watch a tool go that fast. You know, but so you're putting a clearance height, and again, this will be a job-wide value. The other place it's used, say we're doing a multiple-step pocket, and I go around and I'm ready to do the next round of the pocket, I will come up by the clearance amount over to the starting point and then down again. Some of the old ones, sheet cam is bad for this. It goes around all the way up to the top, moves over to the starting point and all the way down again and does it. So we were into no air cutting in this thing, okay? So the clearance heights get used in a couple of ways. But again, it's a job-wide setting. So those are your choices. We make that, we say, yep, that's what I want, and there's an OK button down here. There's an OK button. Oh, by the way, one thing that I'm pretty proud of, there's a help button on this thing, okay? And maybe use it underneath here. I just see it. Come on, help.
Use the screen for your mouse. It's easier to read and see at the same time.
Oh, yeah. Where'd I go? There it is, the help screen. Okay. This is a Windows standard format help. It pops up in this case because I am in the job controls screen. The help opens to the job controls screen page. We explain to you what it's all about, what the issues and whatever. And I think the help screen is a pretty thorough and pretty good job on it. I started it, I wrote the first draft of it. I can't spell or I can't type. And Todd went over it and changed about 800 instances of TEH. But between us, we kick this thing back and forth. And I think it's pretty good help. It's a lot better than anything else we ever had. If you want to see the help on the tool select, you can do it. It's got the index over there, so you can open, you know, here's the operations help. So pretty thorough help, goes through everything. It pops up from, I think every screen has a choice for a help button on it. And we did finally print it out, so there's a PDF file you can download of the entire help thing if you're an old paper guy that likes to print out a manual. We generated a complete PDF. So we got a good help scheme built in it. I will say here, okay, we're done with that. Now, I started a new job. Obviously, I've got to have a tool. I'm automatically jumping you to the new tool screen because no job cannot have a tool in it, okay? So here's the tool specified screen. And this took a huge amount of work. You'll notice up here there's a pull down, and there's a tool table. And I can edit that tool table. I'll show you in a minute where you edit the tool table, okay? But I can look down here and I say, all right, this job, I'm going to do this job with a 1/2-inch mill. It populates this input line with everything you need to know. Our tool table carries a couple of values in it, the type of tool and the number of flutes and all that stuff. There's also this ramp angle. We are very good now about ramping down into a job. And you can specify a ramp angle. And like here, I'm saying 5 degrees. So anytime I start a cut, I'm not going to plunge straight down and, you know, shake the machine to pieces. I'm going to make a 5-degree ramp. And I make it over a relatively short, depending on how long and how deep I go, I will seesaw back and forth on that, making the 5-degree angle going down until I've achieved my depth, and then I will go around and cut the part, okay? Now, if you are a plunge guy, you say 90 degrees. So the ramp angle will be 90 degrees, and the program will straight down 90 degrees. So you can specify any ramp angle you want. And that's a parameter that belongs to the tool. Because think about it, some of those carbide insert facing cutters, you can't plunge them down because all the middle of, there's no cutting surfaces in there. They must be ramped. And they can't be ramped either too slow or too fast because they start to drag. So the ramp angle is a parameter that belongs to the tool. And then there's just a description file in there. Now when that tool came up, it automatically calculated the boxes below it. The surface feed comes from the tool table, the material table, and the tool table. It looks at the material table. You said you were aluminum. I've got some pre-entered values for aluminum, and they're based on 4 different tool types: a high-speed steel, a high-speed tin-coated, a carbide, and a carbide tin-coated. And I have a different value, a surface feet per minute for each one of those things. So I look at that, look it up out of the table. I get a surface feet per minute. Chip load is calculated by the diameter of the tool and a kind of standard formula that I forget right offhand. But it basically calculates what a chip load would be. And then it will calculate the speed and feed, the spindle RPM, the feed rate, and the plunge rate. Okay? And the plunge rate, again, is based on the ramp or a factor from the tool table. Okay? Now, you can, if you like those values, if you accept it from the tool table, you can simply hit OK and go ahead. But if you, let's see, if I say, well, at 260 surface feet, I can make that, you know, let me go over here. My mouse go. I can go up there to that box, and I can make that, I'll just say 200. Okay? So if I make that 200, it pops over to doing chip load. But now I can say recalculate that, and it will calculate, okay, if you wanted the surface feet per minute to be only 200, it now calculates a new RPM and feed rate for you, okay? So you can either accept the one from your tool and material choice, or you can enter your own. You can go back now and say, I don't believe in any of that stuff, I want the feed rate to be something. You can go in and enter a feed rate now, and I'll carry it through the program and use it. You don't have to use my calculations of it. That's a helpful side thing, yes.
I presume you can regrind the cutter and take a few thousandths off of it and put the number in?
Yeah, put the number, whatever the tool diameter number is up there, you put that number in. Yep. And you might be able to, might not commonly do that. You got a tool table, it was a ½ inch, but in fact, you ground it down something, so you changed the number here, and then you could hit calc tool properties, and it will recalculate based on that. So you can, a couple of check boxes, you want coolant, flood, or mist turned on, you turn those on. That's associated with the tool. Once you've done the tool and turned it on, we assume that you might make 3 or 4 milling operations. At the end of those milling operations, the coolant will go off, okay? But as long as that tool is in place, the coolant will run, okay? So
chip load is per flute?
Chip load is per flute, so if you have more flutes, if you came in here and said, well, no, that's really a 2 flute end mill, okay? You can recalculate the tool properties. It brought back the surface feed out of the thing, and it calculated feed rate now based on a 2 flute tool, okay? So you can put in your own number if you have those multi-flute cutters, you know, with 6 inserts or whatever, you put all that in. And you do all the right calculations, okay? So we say okay, and we're ready to go. We have entered into the box over there that there is a job settings operation in our program, and there is a tool change in our operation so far. The tool path display shows us an origin point, nothing in it there right now, and it shows us the coordinate axes down here. Okay? Now, let me go back to these 2 that I mentioned on tables and things. There's a config option up here. I can config the material table. Here's the material table that I built into the program, but you can edit it freely. If you, I'm saying for aluminum and high-speed tool, 500 feet per minute, tin coated 650 feet. I put in, and I've got plunge override, okay, percent override. In this case, I'm saying 1. I want you to do those values, but I can actually put in here that, like we got, our plunge rate is always 50% of our feed rate. You want to make it 75% of feed rate, you put the numbers into the material table, and that material table will be saved, and you can add materials to it. If you work in plastics all the time, you can put all of your own numbers in it. We encourage you to fill the tool table with, the material table with numbers you believe in. These are numbers that Brian believes in. It scares the hell out of me when I run a machine at his feed rates, his speeds, okay? But, so Brian believes in those numbers. And looking at industry literature and all that, these are rational numbers, okay? We're not doing anything completely absurd here. But there's a material table, and you can edit it. Again, it's got a help button on it, so you could read about that. There's also a tool table, okay? Oops, why did it not bring up the tool table it was using in the other screen? Because we did bring up a tool table. Maybe I can say load the tool table, and it'll come up with the example tool table. And I say open, that's not the same one, but they're, you'll notice we use a common Windows dialog anytime we're selecting the file. Okay. You bring in a tool table, you can fiddle with the tool table. You got 256 choices, I think it is. Nope, only 128 tools.
Yeah, but you could set up 27 full tables if you want, right?
Yeah, you could have other files of tools and load the tool file that you wanted, okay? The other config choices, tool path colors. Brian and I kick this one around all the time. He likes some pretty weird colors, but you can go in and change it if you want. Like right now, we got this shaded effect. I'll go in here and I'll make that bottom more like that. Okay, and that makes the toolpath a little bit bright. But you can go change your toolpath colors. It's cute. It's not the most, but there it is. The other setting, we have a machine maximum settings that you can make, and those are program-wide. What's your maximum spindle RPM? What's your maximum feed rate? Your maximum plunge rate? And we'll, in the calculations, we'll do all those. If the tool calculation calls for a spindle speed faster than this is capable of, okay, the number will turn red, and a little warning that says the calculations call for a faster speed than your machine is capable of. Okay? But you can enter those in here, and again, those are sort of program-wide.
It won't adjust for it. It won't adjust for it.
It won't, well, it adjusts to the fact that it will use the maximum speed that it's capable of doing. If the calculation wanted to go 5,000 RPM, and this number says 4,000 is all you have, then 4,000 will go in the program.
But the feed rate will match the 4,000 RPM.
That's right. It'll be, those numbers will all get calculated to the same. Yeah. So those all get calculated. Actually, I think you have to hit the recalc. I tried making it in one version where anytime a number changed in a DRO, all those other calculations happened automatically. And I thought that was really cool, and it confused the hell out of me when I tried operating it. Okay, so we took it out and added those calculate buttons to make it obvious that you're asking the program to do it. The bad news now is if you don't look at them and don't change anything, you're going to get the calculated values that came out of the tool entry. You didn't change or update anything. So
if it tells you you don't have 5,000 RPM, you only have 4,000 RPM, and you recal, it will adjust to 4,000 RPM.
It'll adjust the feed rate to achieve the chip load that we've asked for, as long as it can do it. And same way with feed rate. If you can't go, faster than the feed rate, it limits it down. All right. So we've done a couple of things in the job. Let's look at some of the operations now. These things are pretty obvious. The first thing that is probably going to happen is we're going to surface off our stock. So the window opens for surfacing. All of our windows will be this two-sided thing. Over on that side will generally be specifying the X, Y values and the parameters that make sense for the job. On this side, we always have, and this will look almost identical in every case, and some with some subtle variations. Now, this one, notice it says tool starts and ends off the work. It's the facing. If you ask for yes, the origin is 0, 0, just because that's how I'm programming it. The length of the thing is 3, the width is 5. Now, I got this, well, got kind of cute. Suppose I go in here and I make this thing 3. Okay, notice the graphic changes to show you the proportions of the thing you're asking for. So if you forget to enter one of those values and the screen is showing this long skinny thing, I hope it's a clue that says you better recheck your numbers because it looks funny. This picture will be, it's not any particular scale, but it will be the right proportion of what your job is going to do. And that shows up through everything. Most of the jobs have this origin. You get to specify where is the origin relative to this thing I'm doing. In this case, center is checked, but I could say that I want it up in the northwest corner. I put it in my vise, and I've indicated off this upper left-hand corner. Okay, so if my origin is up there, then I'll calculate all of the G-code based on that origin. Z-top is an entry number now. In the old Wizards, Z-top was always 0. The top of work was always 0. Well, if you do a pocket inside of a pocket, that meant that the inner pocket had to go, round and round and round, cutting air. So now we let you specify a Z-top. Okay. Now, I don't do a lot of checking. If you specify a Z-top and that's not the top of the work, it's down in it, but you haven't cut the pocket yet, okay, you're going to do some funny things with your tool. And I don't have any way to really check that to see if you've taken away enough material to make this Z-top possible. I mean, it could very well be that you just like working where the top surface is, at the bottom of the work is 0. A lot of people like to do that, okay? So Z top is then +1 or whatever your material thickness is. So you'd specify it, program will do the right thing. There's my total depth that I want to achieve, and here's my step that I want to make a cut in. I put step over in, I thought it was cute. See, I got this widgets, WX widgets program. I got all these neat graphical things that we never had in the Mach Wizards. So I thought a slider would be cute for the % step over, okay? And you can come down and grab the slider and it'll show you the % step over. I've had a couple of complaints about that. The guy said, give me a break, let me just enter a 2-digit % step over. And I don't know. That's the way it works. So you say, all right, that's what I want to do. I'm cleaning off the top of this 3-inch square. I'm going to go a depth of 1/10 of an inch off of it in 25. Oh, 25,000 steps. So it's probably going to take 4 steps to do that. And I say, yeah, that looks like what I want. So, okay, and I add that to the program. The toolpath display shows what's going to happen to achieve that. And we've added another operation over here in our list. Okay? So we've surfaced off the top of the work. This toolpath, like Mach4, you can grab the mouse and turn it around. You can zoom it. Do all the things you would, double-clicking it will bring it back to the default thing. So it's pretty much the toolpath that was in the old Mach4, except it's the new blindingly fast toolpath, okay, because it uses some OpenGL code and some better programming. And, so there's the toolpath of our first operation, and it's a surfacing. Now let's, let's cut a circular pocket, let's cut a circular pocket in that thing, okay? Let's start out with the origin. Let's make that origin the same 0 and 0. Notice, by the way, that numbers are coming up here filled in already. We keep an IMI file, and every number that's entered for one of these operations, if you do that same operation again, all those numbers will come back. So, for example, this would be a good example here. I'm going to cut a circular pocket, okay, but I'm first going to do a roughing operation. And the diameter of the thing, now we have a 1/2 inch end mill, so we probably want to make this diameter a bigger number. So I'm going to do a 3-inch thing, and I want to cut clockwise. The top of my material, actually the top of the material model, we just took away a 1/10 of an inch, right? So my top of the surface can say minus, hard to read here, minus 0.1 is squared, minus 0.1. And I want this pocket to be a total of 6 deep, and now I'm going to cut in 100 cuts, and I'll make my step over a little bit bigger, okay? And in fact, though, in my diameter, I want to finish it at 3, but let's make this diameter 2.95.
Right, that's got
Yeah, that's probably 2.95, okay? And so let's do that for the circle, okay? So there's my circle, and you see that, you can zoom up, I don't know if this quite angle is right, but yeah, there it is. And you can see that we started making that circle and after, below the finishing cut.
Let me try and change the resolution real quick.
Okay.
I have to do that.
I think this is pretty decent. We're reading it. So we're doing a circular pocket, okay? And we made it in 5 steps, but now I want to do a finishing cut. I want to come back and I'm going to enlarge the diameter, and I'm going to make it in 1 step. So if I go back now and ask for a circular pocket, okay, the same string's going to come up, the same numbers, but I'll change this to 3 inches, okay? And I will change my step over here. I wanted it 0.6, I'll change my step to 0.7, I'll tell it, I'll give it a bigger number, okay? And I'll say, okay, there, now, and I don't know if we can see it here. Yeah, you kind of see the double line in that outer. So now, we had a long discussion about adding a finish number to the screen. And I was going to do that so that you could have specified in that first screen the rough cut and the finish cut. But then I got into the dilemma, what I do about Z. When I do that kind of a thing, I like to make the steps going down, but then I like to make my finish cut one full depth, one sweep all the way around. So I said, I'm not going to do that. The numbers are going to come back in the screen automatically. All you've got to do is fill in the first screen, go back to the second screen, change the final diameter and the final depth. If you like a step cut, you can leave that alone, but you can quickly make your finish cut. So I was going to do that, but we've changed our mind. I'm not going back and add finish. Now, it happens that the key slot, which we really should just call linear slot, does allow a finish pass in it, okay? And it does that thing of making the same number of Z steps. And that's in there because when I started this project, the rule was newfangled wizards, we got to give them everything that they had in newfangled wizards. And the keyway slot in the newfangled wizards had a finish box in it, so I programmed this one to do that. It's okay this way. You can treat it the same way. As I said before, you could do 2 entries and make the second a full depth cut, okay? Make the finish amount be 0, so it, doesn't do it. But I don't know, that was just, my view is it's easier to do 2 steps in the operation and get your finish.
Suppose you wanted to do a disc, make a 5-inch disc.
Oh, you want to cut a circle, not a pocket?
Yeah, a disc. I needed a 5-inch disc, but that, if you went with a 1/2-inch tool, would that already calculate that offset of the tool?
Sure, it takes care of all that.
It's not based on the center of the tool.
Oh yeah, it figures out what diameter tool and it makes the cut. The numbers you enter are the numbers of the finished part. Okay, so if you want a 5-inch disc, you program it for a 5-inch disc. I'll calculate how far outside of that the tool should go. Now, if you want to make a circle, this is a circular pocket. We'll go down into the material. But you wanted to do a circle, okay? So we use the circle routine up here, okay? And it looks like, again, I'm going to, well, let's see, let's leave that origin shifted over, so I'm not on top of that other circle we did. So I'm saying the origin, the center of that circle is still over there, and the diameter of it, I don't know, the 5-inch one's probably going to look pretty funny on this screen. And the material is whatever depth, and I'll say okay there. So there it is, and you'll see that on this one, I'm only cutting around the circle. I'm not doing, and also you'll notice, zoom it up a little bit. See this funny little squiggly in here? That's where I'm doing my ramp down, this sort of sachet down. We talked about doing a helix down, but in this case, maybe you want the inside, or maybe you want the whole, and it gets kind of complicated in the programming of which way. So I leave it, we don't go in, we don't violate anything, but we're going to stay in our cut path. You ask, we know it's valid to cut in that path, so we zigzag back and forth and go around it. Okay. Now in the pocket operations, point down, let's see, get it up here to show that. Okay. Well, it'd be hard to see. But we helix down in the pocket. I know it's a pocket. I know I'm free to cut away everything in there. So instead of plunging straight down, I helix down to the depth I want, and then I start making the circles. Okay. So now here's my favorite. Brian thinks it's dumb. He said, what the heck are you putting that in there for? Nobody does these parts. I call it link. Okay. Now, how many model makers in here have ever made a part that is this kind of a thing? Okay. I mean, God, there's links all over the place. Connecting rods on engines. I just finished number 4, Stuart Turner number 4, reverse gear. There were all kinds of links in that. Okay. Now, right now, the 2 ends can be a different diameter, and the width is a parallel width, so it cuts that kind of length. The other length that it ought to cut is tangents. You specify 2 circles, and it draws to a tangent line outside those circles. One of the things that bothers me on this program is every time I add a new parameter over here, I got to go through all kinds of coding to save that in the right places and to save it in the INI file. Well, just after the other session, somebody was chatting with me about this link, and it dawned on me that I can take the rule, if that width number is 0, means you want a tangent kind of a link. Okay, if that's non-zero, you want to specify the width. So that'll get added. Well, I'm going on to Detroit after this. It'll be a couple of weeks before I'm back at my desk in programming, and then sometime after that, the boat will go on the water. So it'll get added. That's what I have to do. Okay, the taper. But today you get to specify the two ends of it, the direction of cut, the depth, and whatever, and it'll draw your link and cut out your link. Now, I was doing a part this for the Stuart Turner number 4, right? A situation where I'm making a link. There are two towers that stick up out of the ends of that link, but they're of different heights. And I had a square block of stock to make it on. I put it in the vise, and I first did a finishing cut over everything to establish a 0 and a clean top height of the top cylinder. Then I made a rectangular pocket that took out everything except the top cylinder, everything over to the end, by the depth being the distance in height of those two rectangles. Okay? So I did a rectangular operation to get down to the first level, second rectangle to get between the towers. I took all that out with a separate rectangle. Then I did a circle around each one of those towers down only to the level of the top of the link. So there were two circular operations. Then I did a link operation that went down and around the whole thing. I cut the whole part and I did the whole code in the Wizard. And of course I forgot to put it, this is a new laptop I bought just before this. I forgot to put the job file up here. But that was an example of making a fairly complex part by doing a multiple operation. Now I talked about the manipulations over here. Let's say that I really want to cut this circle ahead of doing the pocket operation, okay? So I can do that, and now the G code will come out with that circle being cut before the other ones get cut, okay? So I can rearrange anything in that list just by moving them up or moving them down. I can also come to that list, and I can right-click on it, and I can say, notice I can say enable or disable. I might have a job file that I usually do something in, but sometimes I want to skip a particular operation in that program. I can say disable it. It'll stay there in the job file with a flag on it that says this is disabled. It won't show up in the G code, okay? But it will do, but it'll stay there. So you could next time come back to the job and enable it. Or you can go here and say just delete that job, okay? Do you really want to do that? Yeah, okay. So there it is. It's knocked it out of the file. It's regenerated the CAD without it, okay? And I've rearranged. So you got full flexibility in the way you can manipulate your job and run things around. So the operations right now, surfacing, rectangle and circle, slot is just a slot with rounded ends. Rectangle allows you to specify rounded corners on your rectangle. Surfacing a rectangular pocket. Okay, if I do a rectangular pocket, okay, right now see I'm doing a pocket, way over 20 inches. Let's move that pocket back to an origin of 2 inches. And let's make it a 3 by 3. Now notice the corner radius is 0. Let's make the corner radius 1. Okay. So now I've got a nice corner radius, and I can say OK. And there's a rectangular pocket up there. Strategy for rectangular pockets is I go to the center, helix down, and then I start a zigzag back and forth, enlarging the hole until I get out far enough to where I start making the radius cuts in it. Okay? That one blocked me for the longest time. I couldn't figure out how to do that. And Brian said, come on, it's got to get in there. One day I said, it turned out to be almost trivial to put it in the code. I was thinking outside in, and I was doing it inside out. But, anyway, so we can add rectangular pockets, circular pockets. Now in drilling operations, we got really kind of carried away here. The obvious bolt circle, everybody needs a two bolt circles. And you can have as many, whatever diameter, whatever number of holes. You can specify a starting angle so it doesn't have to start. Normally it starts at 3 o'clock. Okay? But over here, what am I going to do? I can do the normal drill cycles, G81, G83, or G73. Those are, the G81 is a plunge, down and back. G83 is a deep hole, which goes down and backs up. I forget how much it backs. It doesn't come out of the hole, it backs up.
G83 comes out of the hole.
83 comes out of the hole, and 73 pecks, but without coming out of the hole, okay? So those are obvious drill cycles. Now notice that one called hand drill, okay? I happen to have a mill, it's a jet knee mill. Z-axis is the table. The table comes up and down, and I can use the quill freely. And when I'm doing a delicate drilling operation, I just like to be drilling it by hand. So I come into this hole drilling operation, and I specify hand drill, and what it does is position the table to the right spot, and it executes an M1. Stops, okay? I drill my hand, hit the start button, it moves over to the next one, and I do it by hand. So I can hand drill. So we thought that was kind of cute. And then we said, well, what about if we want to do like a counter board around something? I want to make a counter board on it around the bolt circle. So we have a circle cut and a pocket cut. Now a circle cut is there because let's say that I've done a half-inch hole and I've got this still half-inch tool and I want to make a 3/4 inch pocket around that. All I can do is one circle cut around there and the tool will clean out my counter board okay. But if I wanted a great big counter board, I would choose the pocketing operation. And both of those wind up calling the exact same G-code routine that my cut circle and cut pocket uses. So all that code is shared, and if I find a bug in it, I got to fix it one place, and it gets fixed in both of the others. So let's just, to show that, let's ask for a pocket on this one. Notice this changes a little bit to explain what these numbers mean. We'll leave, just because entry here is so awkward, I'll just leave all of those. Ooh, that's a problem. Dialogue is too big. Just get the, that's the problem with this screen. I haven't seen that at all. Okay. So you see it's done my 5 holes, and it's done on each one of them. It's done that spiral down the cut holes. So my bolt circle can be 6 different ways of, when it gets to station, doing whatever you want. Okay? Now, the other ones, you can do a line of holes, okay? Again, specify the origin and the angle and the increment, and this thing will generate a line of holes, and you get the same choices about what you want to make. The help button is, and then close buttons are off the screen entirely. Make that dim taskbar go away.
Is that your resolution problem?
Yeah, it's a screen resolution.
Right-click the taskbar and see if you got a model height.
I just looked at that.
Other properties. Model height, second one down, second one down.
What will that?
It'll just go away when you're not there. You can help you.
Look at that, when I move over there.
If you go quick,
It's still a resolution.
Oh, wait a minute.
That's not that good.
That's not that.
Oh, that's the exit of the program. That's, this window got open and it didn't draw those bottom things. Oh, yeah.
open it again.
Yeah.
If I try it again now.
Oh, it's still a resolution.
No, it didn't write the buttons.
That's because your resolution.
Yeah, resolution. I'll have to look into that a little bit. We haven't set a minimum resolution for this screen, but obviously we got a problem. Anyway, we can do a line of holes with the same drilling cycles. I can do a rectangle where I drill the outer perimeter or I drill the entire matrix with a click. You know, it says outside or fill in the perimeter. And I can do a list of holes. A list opens a spreadsheet, okay, of XY values and has an import button. So if you've used an Excel spreadsheet to create a, funny list of holes that you want to drill, the list, let me see if it'll come up here, just so you see what happens, okay? The list of holes gives you a table that you can sit here and type them in, but, and damn, it's down off the bottom of the screen, there's a button that says load from a file, and it take a standard comma delimited Excel file and fill that table with it automatically. Okay? Well, sorry about that screen resolution. So that's what we do with all of the drilling cycle things. All of them work with the same. You notice things that look alike, that's because I want to keep code alike in all of them. So that right-hand side of all of the screens does basically the same thing in every case. The left-hand side calculates the direction where the next hole is going to be. Okay? For fourth axis, I do the gear cutting and the spline cutting only because my rule was if it was in the original Mach4 Wizards, I need it here. Okay? So those are there. There is a button, and you know, I think that's lost. I don't think that bottom of the screen looks right here. I'm sure there's two buttons underneath there. Yeah, the show G code and the save G code button are below that white box. So I can't show you. There's a button that, if you just want to see the G code, there's a button you click. Now, if you have not got a license, that little button says tough luck. It doesn't display the G code. The save button will save your G code if you've got a license. Actually, the buttons will be grayed out. If you start the job up and you don't have a valid license, those two buttons will appear, but they'll be gray disabled. Okay, so you can't click it.
So explain the license in multiple computers.
Okay, the license thing here, if I wanted to license this one, I would go to help about. Okay, now, I don't know who came up with that funny looking icon. Okay? I don't know what they were thinking about, but there's the icon for the product.
I was going to ask where your hat was.
But unlicensed demo, your name should be there if you got a license. And then there's that string, okay, of gobbledygook, which is what the thing calculated, okay? Now what I can do here is I can say click this to copy it to the clipboard. So it's like doing a cut operation. So the clipboard is now holding that string. If I go out to some editor or my email program and do a paste, that string will appear. What will happen when you want a license, you click the button on the website that says I want to buy a license. And I don't remember how it deals with PayPal or credit card, but it takes you through the dialogue, how are you going to pay for this thing and whatever. And when you finish it up, this is almost fully automated, but Scott still gets in the loop. There's an employee of the company, partner of the company, Scott Nichols, who handles all the licensing. When he reads the email, and he does it many times a day, he will respond to that email with a license, okay? But you have to send him the string. So I don't remember if you're sending email. I haven't gone through that cycle yet. But when you send the email, if you've got this number, then he will send you back a license key that goes to this machine. And the license will only be valid on this machine. Okay? And all you do is when you receive the license file, you put it into the right folder, the folder where the Mach. Did we change that? We talked about changing.
Yeah, you just hit the button. That load button right there.
Oh, load a license file. Okay, that's right. I remember. Wait, if you click that, and where do you have to have the license file? That's going to bring up a file browser. Isn't it? Yeah. So wherever I saved that file that came with my email, I browse to that, click it, and it's going to load the license file automatically. So we tried to make it as painless as possible. Now, the question about, I'm a hobby guy and I want to run this on, the typical thing, and I do it myself, is I got an office with a big desktop computer and all that junk, and I generate code down there, but I take it up to the shop and want to run it, and sometimes I want to twiddle with it when I get up there and find out that wasn't exactly what I wanted to do. I want to be able to run it again. The way that works, it's, as he said earlier, it's the honor system, okay? You will send an email to Scott that says, I'm a licensed user, and I'm a hobbyist, and I need another copy of the license, and here's my key number. And Scott will read it, and if he hasn't got your name on the S list or something, he'll say, okay, I guess I guess that guy's honest, and he'll send you a license. Now, about the 43rd time you try that, Scott's probably going to send you a message that says, no, wait a minute, what's happening? But that's the way it works. It's strictly, it's not automated. You will have to send an email to Scott. Actually, I guess the right address to use is license at Mach support. Scott reads it. Scott is the guy that's going to answer that one. You can't move it to another machine because this number is coded to this machine. So you can put it on a thumb drive. If your shop machine is not on the network, you'll put it on a thumb drive on your other machine, the license file. And then when you get down to your machine, you'll click this window and you load it right off of the thumb drive. You don't have to copy it to that disk. You just hit here and browse to the...
You know, the key that it generates, is it based on the serial number of the machine, or?
I don't know what it is. It's
Because
a
if I
calculator.
let's say I reload Windows on the same exact hardware.
No, I think you're okay there. We haven't, I don't, Brian probably knows all that.
Or my restore from backup.
Yeah, I think I believe that it's based mostly on things like the Ethernet Mach. That might be one. If you change Ethernet cards, I think this thing will not get the right signature on it. And I don't know what else it does. It does some kind of calculation. And in fact, that's a purchased option. Brian purchased a license from some company that's in the license building. And it may be that only they know the true algorithm for how all that stuff happens. But the procedural thing is, the first time you buy it, you could have run the demo version and got your key signature. You create your first email when you buy it that says, here's my key signature, and you'll get back the license file. You'll load it this way, and you're good to go.
About 2 years or a year ago, I did that for Mach4 on my machine.
Yeah.
With the Mach4 Wizards. And I just put the thumb drive in.
Copy the license file. Now, newfangled, the licensing is much, much weaker in many ways to subvert it.
Now this is all new again, so
Yeah.
my question is, will it work the same way?
What do you mean? Your newfangled license, your old one will not work.
No, I meant to get the new license and put it in the same way.
You get the new license and you put it in with this click box,
But it
and
will still be linked to that computer.
but that computer is the only one that can run that license file. Okay. So I guess I'll have to say cancel here. Okay. But that's the way we track it to
You
a
should
machine.
play a jog file.
Yeah, play the same.
Demo version and then take it to.
Yes, you could do that.
That's what we do.
In fact, that's what we're kind of recommending. Instead of bothering to get 2 licenses, on your desk machine, just run a demo version that will let you save the job file.
And take the
Okay.
jog file.
Take the job file down to the machine that's licensed and generate the G code. That would be a perfectly valid way of doing it. We do let you save the job file. And the job file has everything in it it needs. In fact, I have found the job file will be fabulous for debugging. If somebody tells me something didn't work right, I say, send me your job file. I open it in my machine, and I immediately see everything exactly as they entered all of the numbers. So I know that we're working with the same job file, and I can tell whether, I think I said earlier, a guy a couple of days ago sent me a note that said I was making oversized parts. And I said, send me your job file, and I'll have a look at it. And then the next mail back was, well, I found out my caliper was disadjusted, and the part is right, my measure was wrong. But if he'd sent me a job file, I would have been able to look at that and say, hey, you asked for a 10-inch diameter, and the G code is generating that circle. So the job file has turned out to be really helpful, not just for you to save your job files and move them around like that, but the ability to use it on only one licensed machine and carry the job file around, or to email somebody the job file if somebody's sharing a part with you. The job file is really nothing but a text file with, it's not very easy to read. It's number, bar, just a string of numbers in there. The program knows which parameter goes into which slot. That goes back to the comment I made about making a new field. If I added a new field to one of those operations, I got to edit the job file, I got to edit it about 50 places to know that there's a new field that has to be saved and restored.
So I see you're running on Windows 8 there,
This is running on Windows 8.
and
I did all my development on XP and all my
so
testing.
you and I were conversing earlier on about where the default file locations are set. And I was having an issue with where they're saved. Is there something about run as administrator?
This is, yeah, okay, this is another one of those things that was debated and discussed, and Brian decided that it was important that we follow the Windows conventions. Windows wants you to put executable programs under the programs file folder, and they want you to put user data under the username and the app directory, okay? And so we did that. Be nice citizens, be Windows compliant and all that jazz. But the 8, and I think 7 does too, when you try to write to the program files directory, it says, blocked, you're not authorized to write to program files. And the install fails. That's where you have to run the install script as administrator. So when you've got the script in your folder,
Just the install.
that's just the install. Not, once it's installed, you're done, okay? But if we, oh, come on, where did it put? That thing, we took the screen resolution and rearranged it. And here's my Windows Explorer.
Still not one.
Hmm?
You're stuck in one still down.
Ah, there you go. Okay. If I, well, I just right-click any file here, and no, it's not an executable damn program. I gotta find it. If you right-click on an executable file, the pop-up, one of the lines of the pop-up says "Run as administrator," and if you choose that line, it runs that file under administrator privileges, and then it installs and you're around all that stuff.
Right, the first screen that pops up saying, if you're not running this as the administrator, get the hell out.
Yeah, you know,
Run as the
the installers could test that.
That's pretty much the rule of Windows 8 though.
Yeah, it is in true.
That's the rule. It's
There's
not us, that's a rule.
no software is going to get into that.
Really, I don't think so.
It's kind of.
I mean, most stuff, if that's required to run all installs as administrator, most installers must just do it. Because
See, I don't think
I
you
don't
can do
have to right-click very many things.
Remember, the reason that's in there is to prevent viruses or bad
Right, I
stuff
mean, I'm all for
from
that, that's all
installing.
good, but I guess it shouldn't require me without knowing
Yeah, but
to
I'll bet,
right-click and run as administrator.
we'll have to work this out, but I will bet that it's smart enough that if you try to build into a file that elevates the file's permissions, Windows is going to say, you can't,
Well, then
because
how
that's
do
what
you-
a perfect virus.
Most
Installing to
installers
those,
you
they're
run,
probably not
don't-
installing to those Windows directories, they're probably saving files to unprotected directories, then you don't need to.
Yeah, see, the first versions of this, I created a Mach4 folder, like you used to, and I just put Mach4 Wizards mill, and I put all my code in there. And I was happily using that. Was that your fault that
I like that.
we changed? Oh, okay. Somewhere along the line, Brian said, that's not Windows conventions. I think somebody bugged them on a,
Somebody from Microsoft
from Microsoft. I thought it was some forum guy that
didn't like our.
bugged them and said, you guys aren't following conventions. You're not putting things in the right places. So anyway, that is how it works.
Let's take a vote, let's go back to the Mach4 directory. Who wants the Mach4 directory?
Well, go by, when you're visiting down here, go by the booth and complain to Brian, okay? It was his idea, and I don't like it either. I like even less where it puts the user files, because it's almost impossible to browse to that folder, okay? It doesn't come up under your libraries or your documents, or
It's hidden.
it's a hidden file. You have to tell your Windows Explorer to show hidden files before you can get into that app directory. So it's a pain in the butt. And that's where, I didn't talk about fonts. This is one that I'm really happy with, okay? let me, I'll just get over here. See this little box called Engrave over here, okay? Mach4 has this Right Wizard, and the guy did it was a German guy that wrote it, and the word is that it works if you can figure out how to do it exactly the right way. I was never able to get it to generate any code at all. It's really, he put a huge amount of work in it because the screen pops up a keyboard where you select your characters. He supported it. It was a huge amount of work. And it's just always people complaining, I can't get right to work, okay? So I said, we got to have a right in this thing. And it's got to be just stick fonts, because we assume you're engraving. Remember, this is a wizard. If you want really fancy text, go buy VCarve Pro or some sign-making program, because they'll do all those fancy things. All I wanted here was the ability to be able to put a serial number on a job, or everybody wants to complain to you about where we install our files. Okay.
Does Ron have the source code?
Well, my boss told me that it was going to be this way, so this is how it works. You are still the boss. All right, we'll skip that discussion.
Yeah,
I really like this text engraved. This one I had a lot of fun with, okay? There's a line there where you can put in your line of type. A wizard name, I don't know. Notice my dynamic graphic up there is displaying what you've typed in the font that you've called for. It's using the same font file, okay? And it gives you, this is Todd's insistence, it gives you a length, okay? Right now I'm asking for 3-inch tall characters, and if I want to type that in 3-inch tall characters, I better have 29 inches. It's calculating how far is this string. You don't get to enter that. You can't, that's a box that won't allow input, okay? But let's go back and let's make the text height a mere 1 inch, okay? And so if we did 1-inch high text, it'd take 9 inches to get that, okay? Now, notice the browse line down there, okay? If I want to browse for other fonts, okay, let's see the scripts font, okay? And now I'm engraving in a script font, okay? I thought this was really slick. I really like doing this one, okay? And now if we say okay, okay, you'll see the engraving font done on the scene. The fonts that it uses are a very ancient format that Borland did with a C compiler in some prehistoric era of programming, okay? So they're clearly, nobody cares, they're open source, they're not patented and all the rest of that. But there is a program called Stick Fonts by the guy that does NC Plot. So that NC Plot is a sold program that's on the web, a plotter for G-code stuff. And he did this Engrave program and put it up as a freebie. And he used all those fonts. I called him and I said, hey, if we use the same fonts, do you have any objection? He said, I can't. He said, well, not really mine. They're old public domain stuff. And he said, use what you want to do. But he does offer an editor that lets you write your own font, which you have to buy from him. So you could buy his font editor program and create, you know, as artistic as you are, you can create fonts that will be saved in a format that this program and his program understands. So in the help file, there's a pointer that says, if you want a whole library of fonts, go to this guy's website. And they're free to download. He's got a dozen that, you know, are in there. They're Roman numerals and all kinds of junk in there. So you can load those fonts and put them in here. You could go there and buy his editor and write your own fonts. We only ship with the product, I think the default. I don't know how that script one got in there, but we must have put it, it must have been in our demo machine the last time I built the installer. My plan was, I think I'll leave it there. I think I'll forget to remove it, okay? The plan was we would ship only with the default square block font. Okay? So that's the engraving.
Question. You're engraving. Can you take a radius surface into account? Or only a flat surface?
Only a flat surface. Now, his program, the stick fonts, and there's a link to it, will do some other things like circles. And I could do that someday. I don't,
Like say you wanted to make a
yeah,
degree reader or something.
yeah, right. See, here's my philosophy on this business. Wizards are for doing common and simple things. And they ought to be pretty simple to operate and pretty quick to do and handle all of the standard kind of cases, you know, the rectangles and circles and both. Now I want to add a couple. I want to add islands. I want you to be able to do a circular pocket with an island in it. I'm going to add some of those things to it. But they ought to do the simple things. If you want to do something complex, you want to do V-carve signing, you ought to go use a CAD and CAM program that knows how to do that stuff. So if you wanted to write your text around a ring, I said that's getting up into the realm that I think maybe you ought to be using CAD, CAM program to do that kind of stuff. And that's obviously a soft line debatable about, you know, it would be nice if the wizard did this or that. And I don't know. I will usually, we're open to, you know, if somebody comes up with a good operation that this thing ought to do, tell me about it, and I reserve the right to say that's the dumbest thing I ever heard. I'll tell you politely that I'll think about it. And then I go home and say, that was just dumb, I'm not going to do that. But we're open to suggestions. We want to improve the product, you know. But again, my limit is wizards are meant for common, low-level, simple geometry. We're not going to turn this into, you know, SolidWorks, or, you know, we're not out to knock sheet cam out of business.
You want to do multi-line?
Do two operations. Do one engrave, then do the next one spaced down the right point. Okay. So yeah, you have to do that. You can't. You put spaces in the lines. Yeah.
No plasma?
Well, probably the next wizard that gets released, and it will be this one with some, it will be this base. Now that we have this base where we can do materials and tool tables and edit lines of code and insert and delete and all that junk, where we can do all of those things, that body of code will stay. These operations are separate little subroutines or functions, okay? And I can knock one of those out and knock a new one in its place fairly easily. That was part of the plan. So I see us coming up with a turn package. The operations will be face and diameter and more, but you know, the right, no, that's left. Left side of the screen is pretty much going to look the way it does. The operations list can change. And we have talked about, and it's, as I used to always say in the company when I worked, it's a small matter of programming, and we can have any of those things that, you know, one of us wants to sit down and do. So we've talked about a version that's aimed at the wood router guys that would do, I don't know, squares and circles, but louvers and hinge pockets, I don't know. We you know, whatever seems to make sense for woodwork routers, give them a set of screens. Certainly a set of plasma screens makes sense. But I've never run a plasma, so I don't know much about what the operations ought to be. Brian will probably sit down and come up with a list. But your view is kind of, we want to do the plasma would be the next wizard.
It's almost the same things, it's just...
Yeah, it's just the outside shapes. You're really looking for a shape library.
Yeah.
Pad eyes and gussets.
And it has to fire the torch and...
Yep.
Yeah, the G-code's got to be a little different.
The way this is architectured underneath, that stuff's trivial.
Yeah.
To make it add all these special things, once we do it in one place, it just starts happening everywhere.
Yeah, it turned out, and we didn't sit down up front and design this whole structure. We had one or two sessions on his whiteboard, but it's sort of built up, and I think we've wound up with a really good structure underneath it. There's a couple of internal technical things that we now look at, saying, you know, maybe we could have done better there. But it's a module. It's one lump of code that we can throw out, and the rest of the structure will be there. So.
Okay, well, will you do a copycat? Will that ever be done for Mach4? Or?
Yeah, I want to do a bunch of those. I'm really big onto the interactive programming rather than generate G-code and run it on a machine. If you copycat is one. If you've looked at my turn wizard, NFS turn, that's one that's got, you know, facing, boring, drilling, the common cycles. Down at the bottom, there's two buttons. One says, do it right now, and the other says, save it to my file. So you can set up a job and you can say, I want to face it off, fill in the parameters and say, do that, and it'll immediately pop to the run screen with that code and it'll run. You don't have to do anything else. I kind of like that interactive stuff. But that can't be done standalone. That's got to be integrated into Mach. And as soon as he gives me a screen designer,
Well, I wouldn't say that. This actually can be semi-integrated. Eventually, there will be another option added to this, which will be load into Mach4. And we had talked about the remote interface. This will go through that remote interface and actually have the ability to load the file and do all that other stuff. So you'll just hit a button and it will appear.
yeah. But I hope, or I think, part of the reason that Mach4 has such a cool wizard interface was I just crapped all over him for 3 years about getting us an environment where when the screen opens, we've got a script environment with global variables and all that kind of stuff. Because the wizards in Mach3 drive me nuts. It's a good example. At the bottom of each one of those is a button that says preview the code and a button that says post the code. Now they're almost exactly the same code inside that button. One of them sends it to the screen, one of them writes it to a file. But I had to duplicate all of that code in both places because the scripting environment in Mach, in 3, is such that when you hit the button, an environment comes alive, it runs, and it dies. Gone. It leaves no tracing, it leaves no variables, so you can't share anything between buttons. What we've got now in this scripting environment where when the screen opens, one script will start running. It can have globals, and it'll have functions for each button. So there'll be a function button 3, and when you press that, it'll do its thing, okay, from that same piece of code. But if button 3 wants to leave a flag around it, you've pressed button 3, so that means you're going to the next step. It can do that, and you know, we've got just, it's going to be a wild screen interface. It's going to be a lot of fun. Well, I'm going to have fun, but when you get it out in the field and a bunch of the guys that did screens in the past learn it and get into it, people are going to go nuts with the capability that we've got to do screen design with it right now. And Lou is not that bad to work with. In fact, it's quite good to work with. It's very easy. So we got some. My laptop, I guess, is timed out, but I'm kind of timed out too. Any more?
Your top of part. So let's say I'm cutting a pocket inside of a pocket. So I think it was top of part.
Yeah, Z-top, yeah.
Z-top, so you're not cutting air.
Right.
All right, now, but let's say I'm cutting a pocket inside of another pocket. So I'm removing the air, so I don't have to cut it. Now when I go to my next operation, is it going to crash on me, or is it?
No.
No, you're going to tell the Z-top. You're going to tell it.
Every Z-top for this operation.
Every operation
No,
ends.
you're missing it. Whenever it transitions, it always goes to the rapid.
Yeah. Between every operation, we go to the rapid plane.
The rapid plane doesn't change.
That's job-wide
Yeah.
number, okay? So
Your clearance plane is that one that it comes down to, it stops just before, and then it starts machining. So,
okay. And clearance, you keep in mind, is really a distance, not a fixed Z point. It's not 50 thou plus above 0. It's 50 thou difference or distance above the last cut. So as we pocket down, we get deeper and deeper. We only come back up by the amount of the clearance. We don't come back up to 50 thou above the surface. We come back up by that distance.
50 thou above Z-top. 50 thou above Z-top.
Above the last cut it made.
It's not a return plane, right? It's not a return plane, in other words.
No, it's not a retract plane like in the drill cycles, okay? It's, you make a pass, and then if I'm making another pass, if it's a pocket, I'm going to go deeper. Or if it's even a circle or a square, I'm going to go deeper, okay? I might have to go down a circle case, it wouldn't need it, because I'm going to start where I just ended, okay? But in a rectangular cut, or a rectangular pocket, Okay, I start in the center and I work my way out. Now I got to go back to the center to make another cut. If I just wrap it back to the center, the tool is right at the cut, and it's going to leave a little scratchy mark across there, and the tool is kind of dragging. So we come up by the amount of the clearance, 50 thou above, however deep. If I'm 3 inches deep into a part, I'm going to come up 50 thou, move over to the start, go down, and do my next cycle. Somebody back there was ready.
This is 3 axis only, right? This is 3 axis only?
No, it has 4 axes.
It has the 4th axis in the gear cutting and the spline thing.
Like for a rotary?
Rotary table, that assumes that your gear is in a rotary table, and I figure out, you know, rotating. And now I do something different here. The Mach4 Wizard used subroutines. And everybody always, well, I don't understand. There's no code in this thing, and the subroutine had to go into a different file, and then I got into the problem, okay, where am I going to put the subroutines? And I said, screw it, I'm going to expand the code. So if you look at the code, you're going to see move, rotate, and it's going to be a long file. It's going to look pretty repetitive because it is, okay? But I just figured that was easier to read. You know, my view is that subroutines and things like that were invented back in the old days when they had limited memory and people needed to keep programs short and stuff like that. We don't have limited memory. We can make, you know, 10,000 line programs if we need to. And if it's simpler in the code, I'm a real keep it simple guy, okay? The more complex you get, the more ways it can get screwed up, okay? And if you start, yeah, the subroutines work, I'm not knocking that, and subroutines are good things, but I'd rather expand that code and make it just obvious to anybody what's happening in there. But those are the only operations that we do right now with the 4th axis. Gear and spline is simply cutting a pocket, rotate and cut a pocket. Okay, so it's and in fact it really does use the keyway slot code for cutting the pocket. So it's got all the parameters, and it will operate in exactly the same way as if you were cutting a keyway slot on a flat surface, and then it'll rotate the tool and do it again.
You say rotate the tool, what do you mean rotate the?
Yeah, rotate the work by one, however many teeth you ask for in it.
What about a timing pulley?
Timing pulley?
Hey,
You can do a timing pulley with that if you had the right shaped cutter, or if you could live with not having exactly the right side profile on it. But that would be an easy one. You'd specify the width that you want it between the teeth, and you'd specify the number of teeth you wanted on it, and it would generate the code for you. You'd have to have an end mill smaller than the pass. Okay? And you're getting, I think on a proper timing pulley, there is some angle to the side, and there's a little radius at the top. But when the timing pulleys are, you know, 20 bucks or something, making one wouldn't be a bad thing. And if I had to sit there with a file for a few minutes and round off some teeth, it might be. You could grind the profile on a fly cutter, and this code will generate the right code for you. Now, the only problem with that is this code assumes that we're cutting with an end mill on the top.
Use the gear.
Use the gear. Use the gear routine, because the gear routine is exactly that. It wants the form tool, and it's going to make passes and rotate and make passes. And so if you ground the form tool to the form of a timing pulley.
Now what about just using the axis to rotate to the different side?
There is no indexing feature yet.
What
You want us to be able to cut a rectangular pocket and then flip it 120 degrees and cut it over the indexes.
Well, that would be a pretty simple, write the program with as many pockets as you wanted.
The graphics guy hasn't added the 4th axis in.
Well, I can't control that. And then go back and just add the circle, add the movement of in the code. Oh, that's one other step that I think will get added fairly quickly here. A lot of people have asked ways to put in custom code. And I'm thinking of creating an operation that is just custom code.
And then you can put it
Okay? And so you could do that. You could do pocket, custom code, and you'd write, you know, G, A 5 degrees or whatever. you wanted. So you could write one line, do a pocket, do another custom line.
So
So that
it wouldn't be just a pocket, you can do
you
anything.
can do anything you want, rotate, do anything you want, engrave each face of it.
Write that down, you
You
have
know?
that.
So all we have to add for that is the operation that lets you, now you can do that right now with an editor. We haven't linked this into our G-code editor. We're going to do that at some point, or? Okay.
Why can't you just use like Notepad?
Yeah, you could just.
Well, the idea of this is, let's say you can save the job file, then you save the job file, you get all those things that you added in. If you go back and change it, you want to change diameter of the tool or something, you can drag it right in, and then just start working on it. So it has to be something that's done in the file so that all that stuff is saved for you.
But that operation just added a line of G-code. And again, it'll have a big warning that says, you wrote it, you gotta, trust it.
And like I said, the toolpath will show you what.
There's no way I can test that. I mean, are you writing G-code that is not gonna?
Yeah, of course, but yeah, that'd be great.
Now, you can, I say, you can go do that with an editor right now. But I think that will be one operation. There've been a couple of thoughts about useful ways to do that, so.
Is the manual X, Y, and Z in this newfangled wizard that you want to use like now or the other one?
The power feed kind of thing? No, but that'll probably get done pretty quick too, because that's one that I like. But again,
Get my door?
you can't, power feed?
Well, I got that annual ones, I don't know, say, no,
Yeah, that's gonna work just fine. Don't they distribute a pretty straight Mach with their system, or do they figure
Mach4 it works off.
but they don't figure out with it, do they? They don't improve it or anything. Then that wizard ought to work just fine. And
Unless it's different, screwed up there.
no, it doesn't know anything about that. If your program moves X and Y, then the power feed ought to work just fine. Power feed's about to get a taper operation. Okay, the guys over at the railway talked to me about having a button that says, right now, you push a button that says move X and a button that says move Y. There'll be diagonal buttons that say move X and Y at the same time. Okay? So if you were cutting some diagonal lines. I have a version of that that's turned, and we use it at the railway village for turning railroad wheels, tapering them. And they use the power feed. This thing takes about 20 minutes to make one pass. I mean, we're talking railroad wheels and big old slow cutting things. So I did that wizard for them, and then I made it into a real one. But
When you come out with a lathe person, is that going to be an upgrade or is that a separate deal?
It's a separate license, and the rule is, if you buy 2 licenses, then you get the rest of whatever we write as part of it. So let's say we did mill, lathe, plasma, and wheel. And you're like, wow, I really need lathe and plasma. Well, you're going to get mill and the wood stuff too. Because once you
you don't have to buy more than 2 of it, and then any of the rest. And we certainly will do something on lathe as soon as we're ready or able to do that.
Are you going to drop D2NC from Mach4?
C2.
D2NC.
Oh, that's a separate.
That's
Yeah,
that's someone else.
Yes, you're going to drop that option in the 4.
Where is it an option? It's not.
On 3, you could load it in.
Oh, let them load remotely?
Yeah.
No. If they want to add that, they will have the capability. That's part of the remote interface stuff.
Okay.
Yeah, definitely. No, we're not trying to lock people out, we're trying to let them in.
So you a sheet pan or anything,
Any of them.
they look directly now.
Yep, they will be able to do that, and they'll be able to do more. They actually could control the machine.
All right, anything else?
When is this going to be available?
This is out now, you can buy it. We've already sold a bunch of licenses.
What's just at the website?
It's on the website.
You can find it.
Well hidden, it's.
Yeah, very well hidden, I must say. We got a new webpage coming up for a reason.
Good, it's out there. Look under first, just look under the downloads page, and after the Mach, go down a little deeper, and there's a line that says,
Newfangled mill.
Newfangled
wizards.
mill
Yeah,
wizards.
yeah,
So this is a free download and you
It's the same way, when you run it, this was running as demo here, because I knew the laptop and I hadn't bothered to get the key. I'm glad that this thing, the screen resolution cut off the show G-code button, so I couldn't demo it. Because I don't have it licensed, it wouldn't have shown the G-code.
Well, and that's the other part. You can run this in as many machines as you want unlicensed. You only need, one license to produce actual G-code.
You can create job files all over the place. You can exchange job files with shops or friends, or people who are working on the same parts or whatever.
That's a great feature, because somebody else's machine, you can always share G-code, but this way they can post it on their machine.
They could kind of post, what they would probably do maybe is change tool diameter or something like that, but they use the same steps, and then when the G-code got generated, it would take account of the tool that they used, where, they would have to edit, they'd have to put it up, go down that screen, choose edit tool, and edit. I didn't show that here, but you could have multiple tools within a jump. You might open with a fly cutter for surfacing, and then you might have a tool change to a 1/4-inch mill, and then do some pocketing or something. That's cool.
Now, if you wanted to pocket, I've run into, with certain softwares I've used, if I wanted to cut a pocket, let's say I want to drill a hole, a 1/4-inch hole.
Yeah.
And I happen to have a 1/4-inch end mill in my machine, and I don't want to do a tool change below the drill.
Yeah.
So I want to mill a pocket.
Yeah.
I've had some, so I'm not sure if the old Wizard was this way or not. I'm not sure where I ran into this problem, but it would not let you mill a 1/4-inch pocket with a 1/4-inch mill.
I think my test is that the pocket must be greater than the tool diameter.
Right.
So it's not going to let you
So I'd have to
plunge
do
straight
it.
down, because it wants to do that rotate. And
So assuming I had a center cutting end mill.
yeah. So I think what you'd have to do is,
Got a 251.
a 251 pocket or something, and then it would have it where it'd be happy with it. So what are we doing here?
So
Okay.
here I've just added a 1/4-inch tool. This is neat. Now, we've got this whole circle we did over here. I'm going to shift it over like that. Now, when I click on this and I move it up, see how it instantly changed those? So it took into account the tool instantly.
You didn't even have to recalculate.
No, nothing. It's
Well,
all on the fly. Everything happens now.
And notice you could put that tool change and just push it up. Say we wanted to do the pocket and the hole with it. So you can add one at the bottom.
Yeah, you can add one at the bottom and force that tool
And
up through.
Push it up in the
And
list.
that same tool for the ramping and stuff, he probably already showed you the ramping.
Yeah.
We can edit it and we can go in and tweak that stuff. Or just take out the ramp is 0. Everything's square.
So if the machine doesn't have a tool change on it, you just go into a stop mode, so I'm all new to these, so.
Yeah, it'll do whatever the machine set up for.
So it'll give you time, or it won't resume cutting until.
Yeah, until you hit cycle start again.
Right.
This is using the same post processors you selected with Mach, or?
No, this doesn't have a post. It's,
It kind of just generates native G-code.
yeah.
In the simplest form. Again, keep it simple, okay? I don't use cutter comp and offsets and all that kind of junk.
So
it's going to use pretty simple G0, 1, 2, and 3, and the drills, the G81, 83.
So if you're doing tool changes in your
arcs. Well, yeah, we've got that arc slot where you can make
Those are all ours.
arc slot.
I think the
We always
doesn't
use
Mach
IJ
itself
incremental.
have configuration associated with the tool change command. So this is just going to give you the G code for a tool change, and whatever you have inside of Mach for the configuration
Right,
is going to
for
determine whether
changing my
it pauses
TLOs
or
and all
what it
that.
does. Yeah, that's your configuration inside of Mach 3 that's doing that for you.
Just a comment. When I print that simulation there on a laser printer, well, I get a nice image on a laser printer.
If you
The
did
reason I
screen
bring that
capture.
up is that in NC plot, it makes a nice image on the screen, but an ugly thing that I can't see on a laser printer.
What do you do, just a screen capture? How do you get your image?
Yes.
You put it up and you do like that all print screen button and capture a screen image? Or do they have a button that says print?
I don't know that detail.
Okay.
Yeah, I think what Brian's doing here is what's gonna help you out is changing your colors so that it's something.
Yeah, unfortunately, that's about what it would end up like. You lose
Yeah, if you
all
print it
the
on
definition.
Yeah. Depending on
Well,
how you.
But this is my Ron CAD.
Okay. But in NC plot, even the line width was so fine.
Yeah, that's gonna.
So little things like
Well,
that.
I
that's all
tell you that
comment.
we did screen captures all over the place to put them in the manual, the help screens, and those came across just fine. So we did a screen capture and pasted it in the documents.
Might be the tool you're using to take the screen capture is your problem.
Yeah, you know, we would have gotten better images if we had done this. I never thought about it, putting tool colors to black and white.
I have all the images.
Yeah, but it worked actually in the manual.
They're
The
like
color.
a box.
If you're looking at the manual on a color screen, they're going to look just like the application. If you print out the PDF file, they're going to look a little blackened out, probably.
Oh, you showed them you had help files?
Oh yeah, we went through the help file, we talked about, actually I showed you a help button that brought you up. There's a help at the top that will bring you straight into the help at the table of contents level. Okay, remember I showed help from new job and it brought you immediately to the new job page. This, since you're just asking for general help, brings you up to the top and you can click any one of those things and go get help on, what? What'd you do? Operations. Go down to surfacing. Okay. I must have missed that. I got a bad link. Because the mill operation screen is there, but the link on that one is.
I had to pick the one you had.
Yeah, it's the only. Damn kids that you got to work with. You know, it's really tough when you got to work with these kids.
You wanted to show it, wouldn't have happened. Murphy's Law. Yeah, that's a screenshot right there. So,
Windows 8, I love it. Why do they think I love that crap to pop up on the side anytime I put the mouse over there? But that's Microsoft doing what they think I want to do on my machine.
Thank Apple for that. Thank Apple.
Yeah. And then Microsoft has to go copy.
You see, just days ago I read a news article, sales of PCs are down 14% for the past quarter, and they're blaming it mostly on Microsoft and Windows 8. Apparently everybody that goes for it hates it, and they're just not buying PCs. I don't
I
know.
think the biggest enemy of PCs is those tablets.
I can't figure out how to turn Windows 8 off.
They get the start screen?
Yeah.
Oh, that's easy. You download a program, either Start is Back, or and it's
Easy, not I can do it.
There's where my screen comes up. There's the task bar, and there's the start button, and it looks like a start button. Okay?
So that's another program.
It's an add-on. There are 3 or 4 of them around. The one called Start is Back cost you $3 for the license. And it worked, but the one I got here, Google Start button Win 8, and you'll get a list
Which
of.
one do you have?
Plug out of the wall.
So how do you, panels up there?
There is a way to get
Right.
stuff. I forgot what it is.
Work is upgraded when you said.
Well, as I was saying, because it's usually bad, so it's like every other.
I have one called Classic Shell.
Windows 7.
In the CD.
You should be a nice one.
We're going to be around both days, be able to run this up there, run the Mach stuff.
Are you going to do another campaign?
No, he's not going to be around. I promised Gary, we will put up a schedule of 3 or 4 CNC seminars. Look at me up again, I'll build Wizard. I'm gonna try to get things going too. We'll have 3 or 4 seminars tomorrow, but if you've heard this, it'll be a short version, it's probably scheduled.
That's what
And great personal thoughts. I spent about 3 months.